All right. Well, hello everyone. Welcome back. It is Sunday, January 2022. Yesterday I did a video on a topic. What was it? I should know these things. Anyway, I was talking a lot about. I've been talking a lot about the age of chaos and how things are going to proceed from here. Why we haven't been able to make any changes to so far, and probably why we won't be able to make any real effective changes going forward. Someday in the future, someone will. If you are one of those people from the future and you're watching this video now, then you have my sympathies. I'm really sorry we didn't do a better job. We probably could have, but for a lot of reasons we didn't. And I'm not making excuses, but I feel compelled to sort of describe what it was like for us and why we did things the way we did, or on the other side of that, why we didn't do things that maybe we should have done or should have known that needed to be done. This is a massive problem. Climate change is a massive problem. It's been known for a long time. The possibility of it was known in the late 1800s. It was being studied pretty actively in the middle of the 1900s, and it really sort of hit the pavement, so to speak. Rubber met the road in the 60s and the 70s. That's when fossil fuel companies started doing their own research to try and get ahead of the problem, so they could start running their propaganda engines to make sure that no one ever questioned their product or the use of their products or the impact of their activities on the planet and the biosphere and human civilization. They just didn't want that to happen. So they were successful. They were entirely successful. It was an easy sell. There was no pushback from people. Like, what are you saying? That can't be right. When they said, yeah, it's not a problem, people were like, great, glad to hear it. Here we go. So yeah, it was an easy sell. All they really had to do was just extend themselves a little bit, cast doubt on science, which is what they had been doing because of big tobacco, and the rest is history. So there's an entire generation, really 2 generations of people who were completely paralyzed, absolutely paralyzed by, propaganda, disinformation, and just willfulness, just greed, selfishness. Didn't want to see change, didn't want to talk about it, didn't want to face it. It's human nature, I think, to be that way. People don't really want to deal with it, with difficult things. So it was predictable, really. And like I said, the energy companies, the fossil fuel industries in particular, had a pretty low bar to clear. It was very easy to sell the idea that this is really not a problem. We are now heading into an era of chaos. That's the super context of this series of videos. The age of chaos is what I'm calling it. I don't know how long the age of chaos is going to be. A new system, a new Earth dynamic system will emerge. We will repattern our civilizations and societies and habitable areas around that new system. Hopefully it leaves some room for humans on this planet to thrive and do well. It's not guaranteed by any means, but I guess we or someone, maybe some of the people in a position to watch these videos, will be able to start answering that question. Is there going to be any place for us on this planet when this planetary excursion, when this wholesale system change is finished and has plateaued and has reached a new equilibrium? So we'll see. Someone will see. I won't be me. I don't think I'm already, 62, going on 63. So, 20 years, I suspect we'll still be in early days, but I could be completely wrong. We really don't know how fast this is going to develop. Now, the reason why we don't know how fast this will develop, and the reason why we don't know where it's really going to go, and the reason why we don't know uh, the sequence of events from this point, has to do with the reality, the fact that the Earth dynamic system, including the climate system, which drives the weather system, is a chaotic system. When I named this series The Age of Chaos, I wasn't really talking about mathematical chaos like what I'm alluding to now. I was talking about the chaos that comes about when you're planning for how you're going to live, how you're going to have shelter, how you're going to eat, how you're going to clothe yourself, where the planning that takes place around these activities becomes unpredictable. You cannot project it anymore. You don't know where your next meal is going to come from. You don't know where the crops are going to grow. And all that stuff that used to be regular and understandable and predictable becomes chaotic. So that's the age of chaos, where everything that we thought we understood turns out to be no longer be valid, and we don't know what to do in the future. But there's another type of chaos here. There's another type of chaos, which is mathematical chaos, or engineering chaos, or biological system chaos. So these are chaotic systems. We're not talking about a chaotic environment like you go into as your civilization collapses. You go into a chaotic environment. Trying to find things and make things work becomes difficult. There's also system chaos theory. You've heard about the butterfly effect, which nobody understands what that really means. They think they do and they don't. They don't. Nobody understands that. I'm not even sure the person who coined the term understands what the butterfly effect really is. But that's a reference. The butterfly effect is a reference to chaotic mathematical chaos, chaotic systems, three-body systems, things like that. So I'm going to talk a little bit about chaos. So this is going to be somewhat technical. I mean, most of my stuff is a little bit technical. I don't really dumb it down. You're just getting it fire hose straight from the source. Okay, I'm not filtering at all. I don't even know who you are. Why should I filter for you? For all I know, you've got a PhD in mathematics. Doesn't do me any good to talk down to you. So you're just getting it. This is how I think. This is what I think. This is how I think. This is how I think in my own. This is the thought processes that go on in my mind. And you're just getting them. Okay. So it's technical. It's nerdy. There's a lot of jargon. There's a lot of very specific use of words. And I will often repeat myself because my use of words is very specific. Words matter to me because I'm a scientist and an engineer. We struggle for clarity. You can't have engineers uncertain about things they're working on. When you see a number, there has to be units right next to it. Is that 2 centimeters or 2 inches? It makes a big difference in engineering. Is that 5 kilograms or 5 ounces? You need units. We need to understand what those units mean. We need to understand what numbers mean. And we use words in particular with absolute clarity. We define our words and then we use them as defined. It's very much like law, whereas and wherefore and all this stuff, and precedents and antecedents and all this stuff. You have to define your environment and define your terms with absolute clarity. So today we're going to talk about chaos and how that applies to climate change. Now, the actual subtitle of this video is Fighting Climate Change. And I appended the negation, not. So not fighting climate change. But this video is about chaos, mathematical system chaos. And I'm going to tie these two concepts together. I give you the shorter story. The shorter story is neither you nor I, nor any combination of you and I, or any other group of people, or any country, or any organization, or anybody, anything, anywhere, going anywhere, doing anything, is going to fight climate change. That's the short of it. You're not going to fight climate change. You can fight a lot of things. There are a lot of things you can do. One of the things you cannot do, and I'm using the word cannot as in it is not feasible. It's not possible. I don't mean cannot like you're not allowed to. I mean cannot means in physics, you're just not going to be able to do this. Fight climate change. So let's start out by talking about chaos. Let's start talking about chaos. Mathematical system chaos. Let me bring up my notes here. So again, it's worth repeating. We are wordsmithing here. We're wordsmithing. Words matter. You're going to take a little voyage into my mind and how I think. Most engineers, most scientists are a little bit. Let's face it. I'll admit it. I'm not shy about this. A great many of us are a little bit on the spectrum, as they like to say, in polite company. We're on the spectrum. A lot of Asperger's syndrome and various combinations of that, and various kinds of over attention to detail and rejoicing in discovery, and in particular of discovering systems, operating systems, how systems operate. And so when I talk about these topics, I get really excited about the words and the concepts that are contained in the words, that are behind the words. So we're going to be doing some wordsmithing here, and you're going to have to just adapt to that. I think it's going to be really rewarding. I think this is going to be a really excellent exposition, and I hope you find it to be similar, because this is kind of me giving you a glimpse into my operating system, really, and how my mind operates. My mind operates this way, and most scientists and engineers and like-minded people, mathematicians, we all kind of have the same operating system. And when we are solving problems and talking about things, we can talk to each other where we can't talk to people who don't share our language and our operating system. So this nerdy part I'm about to get in here, this wordsmithing, explaining things and how to talk our language and think our thinking, is exciting to me. And at the very least, maybe you'll find it interesting or illuminating. It may explain might explain some of your quirky friends if you happen to know any scientists or engineers or mathematicians, physicists, and that much. So again, our discussion of climate change has to at least get into a discussion of chaos, and it has to get into a discussion of problems. Climate change is a problem. Most people identify it that way. They're going to fight climate change, solve the problem. Various people are approaching this and saying, I have a solution. Well, I have a better solution. Well, all of our solutions are solutions. We should pursue all solutions to the problem of climate change. And none of that's really going to work. It's just not going to work. They get off on the wrong foot, and this is easy to do, and I don't want to be too pedantic here. I understand there's a difference between talking and engineering. And even engineers just talk, right? Hey, Stan, I got a problem. I'm working on this bridge layout, and I'm doing some structural engineering calcs on the structure, and I'm not sure about this. Could you look at this? And they talk about the problem and the problem and the problem. They kind of understand what they mean when they say, I have a problem here. Can you help me find a solution? For them, it's an investigative process. They don't even know really what their set of problems is. They're digging into it, and they know, as engineers or mathematicians or physicists, that as they dig, they're really building a story about the project they're working on. And some things are problems, some things are not problems so much as they're just parameters. This is what it is. You're building a bridge, and the canyon is so much wide, and the bridge has to be so high from the bottom, and the winds blow at a certain miles per hour most of the time in the afternoon, and so sometimes these are problems. The canyon is too deep, the canyon is too wide. It sounds like a problem, but it's not really a problem, is it? It's just a fact. I mean, if it's a fact that you can't deal with, then I guess you can't build a bridge there. But initially, it's a fact that presents a problem. How are we going to bridge the span with the types of materials we actually have on hand? available to us with our budget and with the time constraints we have. And so engineers will use terms in a loose kind of way, but we need to understand what some of these things actually mean. All right, so let's do some wordsmithing. I want to read a quote that I pulled from a wiki. I'm not even sure which one it was. Discussing the difference between complicated systems and complex systems. In common conversation, most people will use complicated synonymously with complex. Someone might say, well, my relationship with my coworkers is complicated. Or you might say, well, my relationship with my coworkers, has a lot of complexity. And we all get it. But if you're talking to engineers and you're saying, I have a problem here, it's complicated, then that engineer is going to make certain assumptions. If they're being serious, then they're going to make certain assumptions about your problem based on the fact that you used the word complicated. And if you if you're talking to your engineer friend and you say, I have a complicated problem here, at some point he or she might caution you, say, I'm actually looking at this, and I know you said this was complicated, but actually it might be complex. And at that point, they have to start being very careful with their choice of words. And here's why. What is the difference between a complex system and a complicated system? Complicated systems are highly predictable. Complex systems are the complete opposite. The typical example of a complicated system is a clock. A clock. Clocks are complicated. Most people don't even know how clocks work. They're so complicated. And when you open one up, you'll understand why. You don't know why it works. There's lots of gears, there's springs, there's moving parts, there's rotating parts. If you're a watchmaker or a clockmaker, then you kind of understand all that stuff because that's your bread and butter, so to speak. But to a person who just opens the back of a clock and looks inside it looks insanely complicated. And it is complicated. Try building one from scratch. You'll see there's a lot of pieces have to be made, and they have to be made in a very exacting manner and put together in a very specific manner. But whereas it's complicated, a clock is absolutely 100% predictable. Kind of has to be, doesn't it? It's a clock. And you expect this hand to go around in a minute, and this hand to go around in an hour, and this hand to go around, 12 times in half of a day. And you expect it to chime on the hour, every hour, like clockwork, right? It's accurate, it's predictable, like a clockwork, but it's complicated. There's all these moving parts, and they look complicated. There are all these strange organizational methods going on in there. And this thing is geared to that thing, and there's this many teeth on this wheel, and this many teeth on that wheel, and who came up with all this, right? It's complicated. But it's predictable. Things can be very complicated and be absolutely, completely predictable. Your automobile that you drive is one of those things. It's extremely complicated. You couldn't build one. You could open up the hood of your car. You couldn't identify anything under the hood, not one single thing under the hood. And you know that if you remove one thing from the engine compartment, probably several things aren't going to work anymore. It's complicated, but it is absolutely predictable. You turn the steering wheel this way, it goes that way. You push on this pedal, it goes faster, and this pedal, it slows down, And, the fewer interface elements you have to deal with, the easier it is for you as a user, but the complexity of the machine doesn't change at all. I use the word complexity. The complicated aspect of the machine doesn't change at all. And it can be as complicated as it needs to be, or somebody wants it to be, and still be 100% predictable in use. Complexity is different. Now, you can use the word synonymously in conversation if you want to, but for the purposes of mathematicians and engineers and system analysts, complexity is different. Complex systems are unpredictable. They're unpredictable because of their complexity. There's a thing called it's a classic problem in physics. It's called the three-body problem. The three-body problem, in astrophysics, it applies to orbital bodies like planets and suns. Okay, so a two-body system like the sun and the Earth going around the sun, that two-body problem. If there were no other influences, that means really nothing. Okay, the sun and the Earth are the only ones in the universe, and the Earth goes around the sun, and actually they kind of go around each other. But that's a two-body problem. A two-body problem is complicated, but absolutely predictable. And for the most part, the orbit of the Earth around the sun is completely predictable, but not completely. Not in fact completely predictable, because the Earth-Sun system does not operate in isolation. In fact, the Earth-Sun system operates in conjunction with the moon, with the other planets closer into the sun, Mercury and Venus, and outer planets beyond the Earth. And so if you just were to take the sun, the Earth, and the moon together, that constitutes a three-body system. And of course, there's many more bodies than that involved. Venus and Mars are also close enough to tug on the Earth and the moon and be tugged on by the sun. And predicting the motion of the Earth around the sun, when you have Venus and Mars there and the moon going around the Earth, that becomes a multi-body or at least three-body problem. And it's chaotic. The behavior of all these bodies together is chaotic. You can make some very loose approximations for how it's going to behave, but if you run it very far out into the future, you're unable to deal with it. And there are other three-body systems, like a three-body pendulum or a three-pivot pendulum, that are just completely chaotic. A two-pivot pendulum is completely predictable. You add a third arm onto it, and three pivots and three arms, it becomes completely unpredictable. It's a chaotic system. So how does this apply to climate change? Well, you could say, if you want, in conversation, well, climate change is going to be a complicated problem to solve. You can say it's complicated. And when you're talking to your neighbor, wow, climate change, that's really complicated. You can kind of get away with that because you and your neighbor aren't going to really have an opportunity to do anything about climate change. You're just talking about it. If you were talking to your neighbor about climate change, you might describe the problem of climate change as being complex. Yeah, it's really complex. There's political issues, there's economic issues, of course, there's moral imperatives. It's just really complicated, or a problem. And you're using the two words interchangeably, complex and complicated, and you can get away with that. But let's not do that. Let's use engineered terms. The climate system as a set of problems, as a set of challenges, it's either complicated or it's complex. Now, if it's complicated, and if there's a way for us to determine that, and there basically is, we can determine that it's complicated, like a clock, that it's complicated. Then we can study it. We can figure out how it works, and based upon how it works, we can predict where it's going to go, and we can predict with some certainty, some confidence that if this dial gets turned this way, then the system is going to go in that direction. If it gets turned a different way, it's going to go in this direction, because while it's complicated, it is predictable. If we want to say that the climate system is complicated, then what we're saying is, with enough study and figuring out the important parts, we can move this dial, pull this lever, and it'll go that direction because it's predictable. Well, what if it's not just complicated? What if it's complex? Meaning, what if it has elements of chaos? There are parts of it that are simply unpredictable. That the unpredictable elements dominate the overall system. Now, clearly, the Earth dynamic system, which is, the atmosphere, the lithosphere, the biosphere, the hydrosphere, the cryosphere, it already has a lot of compartments. Each of those compartments is both complicated and complex. Some of them are more complicated than they are complex, and some of them are more complex than they are complicated, meaning chaos either dominates or it doesn't. If I had to make a quick assessment, I would say that the atmosphere container compartment is more complex, whereas and so is the hydrosphere, the oceans, ocean currents, things like that. Whereas the lithosphere, which is the rock, the solid crustal part, is more complicated. Now, geologists might say, "Ho, you don't know anything about it." Well, let me tell you about the complexity involved in the movement of the continents and the formation of volcanoes and earthquakes and crustal faults and all this kind of stuff. Okay, fine, I get it. Maybe every part of the Earth dynamic system is complex. Maybe every single part is. I'm willing to allow that some of the parts maybe are less so. The cryosphere and the lithosphere may be less complex than the atmosphere and the hydrosphere, possibly. But if you take the whole thing together, then you have to allow that some of the components, I just named 5, are dominated by complexity. They are complex components. They are going to be chaotic in nature. Their very nature is going to be chaotic. I'm going to lift my table up. So why is it really important to make this distinction? I would submit that if you are going to allow for the supposition that the Earth dynamic system has components that are chaotic in nature, that we really, even if we understood them, their operations are chaotic. They cannot be predicted. If you've done any work with weather or you paid attention to weather, you understand that our ability to predict weather, it's not bad, by the way, but you can only go out a certain distance in time before your models start to become kind of irrelevant. There's kind of a horizon beyond which we can't see. The curvature of the space of predictability. There's a horizon beyond which we can't see past that curve. So, that suggests that there's a certain large-scale chaotic nature to weather patterns. Climate maybe is a little less chaotic, but I wouldn't count on that. And all of these systems contain a good deal of chaos because they're not just complicated. They have internal complexities that we probably will never comprehend. And even if we did comprehend them, that's not sufficient. They're still complex. And the chaos is actually built in. Chaos in this case is not just a lack of understanding. If we just knew more, we could figure it out. That's what you do with a complicated system. You just keep studying it and you find the important parts. You study the important parts really hard, and then it becomes something that you can predict. But if the system is inherently complex and there's a lot of the equivalent of 3-body problems in there, then it is inherently chaotic. It's not chaotic because you haven't looked at it long enough. It's chaotic because that's what it is. It is a chaotic system. Fluid dynamics apply to both the hydrosphere and the atmosphere. And fluid dynamics are chaotic. Fluid dynamics are always chaotic, period. Now, they're reversible. And if you had an arrow of time that you could just flip it and run it the other direction, they can rewind themselves. There are some cool experiments that demonstrate that. It's kind of neat. But going forward with the arrow of time, you completely lose the ability to predict. So the climate system and the weather system, which is a subset of the climate system, right? Weather is just a short-term phenomenon inside the longer-term pattern of climate. Climate and weather systems are inherently chaotic, and because they are complex systems, your ability to have statements like, well, here's your problem, here's your solution, and here's what you'll get. Okay. You can do that with complex systems, but have to be careful. You can do that with complicated systems like a clock. You can say, these are the gears you need to set them up like this, and you'll be able to tell the time. Okay. Guaranteed. Absolutely guaranteed. Yes, it's complicated. Lots of gears, lots of parts. They have to be assembled in this particular way. But if you get the gears and you assemble them this way, you'll be able to tell the time because it's a complicated system, but it's manageable and it's predictable. Where you can't say that about a complex system. Even if you know everything you need to know, you still cannot predict what will happen because it is chaotic, inherently chaotic. So that's our wordsmithing for today, and I want to tie this back to climate change, and in particular, the subtitle, "Why You're Not Going to Fight Climate Change." We cannot fight climate change because we cannot fight complexity. You cannot fight something that you can never get your hands around. I like to tell my wife that when some demagogue or some supposed leader gets up and says, "Yes, we're gonna fight climate change," and everyone cheers and holds up their lighter in solidarity and all this kind of stuff. You can use words like that and stir people up and give them hope and all these other kind of things, but it's not actionable. There's no action associated with fighting climate change. There isn't really any actions associated with fighting the Spartans, or fighting the Greeks. You can say, yes, we're going to go to war with Sparta, we're going to fight the Spartans, but that's not actionable, and your general is going to turn to you and say, excuse me, Caesar, how are we going to do this again? I mean, you just said that and you got everybody clapping and they're all standing up and ovations and this kind of stuff, but what do you mean fight the Spartans? What do you mean? How are we going to do this? And so it's you're going to fight something is not really actionable. So when the rubber meets the road, you walk away from the crowd and you're all in the green room and you're saying that was a great speech and that was a great crowd, and so someone's going to say, okay, now what? Now a true politician will say, well, we should go get dinner and drinks. Okay, but someone who's like a policy wonk or someone who's more operational in their relationship with problems is going to say, okay, I have a question. So you just said we're going to fight climate change. What do we have to do? Yeah, okay, let's go get dinner and drinks. But on this question, you just made this commitment. What are we going to do? I mean, seriously, what are we going to do? What policies are we going to advocate? What, government departments are going to be involved? What government departments are going to take the lead? What are we going to task them with? What is going to be our charter? What are our goals? How do we know if we've met our goals or didn't meet the goals? You say we're going to fight this thing, but operationally, how do we really do that? So there's a certain amount of just politicking when someone says we're going to fight climate change. It's like when someone says, well, we're going to fight crime. Really? How are you going to do that? Really, seriously? You're going to hire police or are you going to fire police? What are you going to do? What's the problem set? What's the solution set? But there's also a problem of, can you even do it? Who's the enemy here? You say you're going to fight climate change. Well, who is the actual enemy? Climate change is not a thing. It's not a thing. It's not a group of things. It's not a group of people. It's really us. So if you say you're going to fight climate change, if anyone's paying attention, they're going to say, I'm not real comfortable with that because that looks like you're pointing at me. You're going to fight climate change. And okay, I know I'm contributing to climate change because I drive a car. I put on about 70 miles a day. Uh, my car runs on gasoline. I can't really afford an EV, and I don't even know that solves the problem anyway. I mean, who's making the EVs? Aren't they using fossil fuels to make EVs? I'm not convinced. So you're going to point at me and you're going to tell me I have to do something different because you decided to fight climate change. And I don't know how that's going to work because they understand climate change is not a country. Climate change is not a border conflict. Climate change is not some, bunch of terrorists. You can't root it out. You can't throw it in prison. You can't, deem it unconstitutional. Although there's lots of people who like to take that approach. We'll just write legislation that makes climate change unconstitutional. Really? Well, and that accomplishes what? But, if it means I can still drive 70 miles a day in my car, sure, I'll sign on for a constitutional amendment against climate change. Why not? If I can still drive my car and that makes you happy, now we're fighting climate change. Fine, good, wonderful. So you're gonna hear a lot of that. You're gonna hear people saying, "Let's fight climate change." Sounds good. Sounds like you're on the right foot. And I have to admit, when I hear people, politicians and leaders of different kinds, corporate leaders saying, "Yeah, okay, fine, whatever, we need to fight climate change." Okay, then that's going to be a good sign. At least they're talking about it. But I hope someone has them by the elbow and says, "Excuse me, I heard you say that you're going to fight climate change, and we didn't really talk about this before you said all that. And it's fine that you said that. I'm not saying don't say that. But I want to point out what you're really signing on for. What you're really signing on for is you're talking about withdrawing fossil fuels from general use. That's what you're really talking about." And the reason why that's your only solution is this. If you have a system, a problem that you've identified as complicated, then there is probably a solution. It's a complicated problem. There's probably a solution. Study all the gears and the levers and the buttons and find out what all is connected to everything. Find out the spot that's not working quite right, that's just sort of broken. You can fix that with a solution. And then, because the system's predictable, you know what your solution is going to do. But if your problem set is complex, then even if you know a whole lot of the gears and the levers and the buttons, what you don't know is what anything you do, what impact that will have on the output of the system, because the system is inherently chaotic, or it has a lot of chaotic elements. And you don't even know, because it's inherently chaotic, there's a certain chaos in the chaos. You don't know which parts of that are more chaotic than others. Now, you could study them. You spend a lot of time studying which parts of this are really sensitive to initial conditions. Which parts of this, if you touch it a little bit, boom, you get massive changes. On other parts of the system, if you move it a lot, okay, you don't get hardly any changes at all, because those portions of the system are a little less complex. But the fact that any part of the system exhibits complexity and the chaotic behaviors that emerge from complex systems, the fact that any of the systems exhibit complexity means that your system overall, all of it containered together, is going to have uncertain outcomes. And you can study it all you want to. And of course, scientists are all about studying things. We just need more grant money. We'll study this. We'll study the cryosphere. We'll study the hydrosphere. We'll study the atmosphere. We'll get all this together. We'll study it together. And we'll do all these studies. And what they're not necessarily revealing is that certain components of this model are inherently complex and therefore exhibit chaotic behavior. So they want to study it. That's what they get paid to do. So why wouldn't they do that? Of course, we're going to study it. It's a problem. Why? We have to study the problem. And I'm not saying that to be mean to people. Of course, we have to study the problem. But at some point, the problem really needs to go away. It needs to go away, or we're going to be in big trouble. So study the problem, that's fine. But at some point, you have to say, now it's time. Let's wave our magic wand and make the problem go away. Well, with climate change, you can't really do that. You can't run the system forward with tweaks and knobs and changes and say, this is the set of things we have to change to make it do this in the future. You can't do that. The system is inherently chaotic. You don't know where it's going to go. In fact, this whole notion that we have 5 years in which to make up our mind, we have until 2035 in which to make up our mind, we have until 2050 to get off of fossil fuels, that we have until 2070 to get off of coal. You hear all these leaders, so-called, and politicians establishing all of these altruistic goals that we are going to do this and we're going to do that. They're invariably out in the future far enough that that particular individual who's ever making those statements will never be held accountable for them. They'll be long gone from the system, might even be dead, okay, died of old age. But if they say it's going to happen in 2070, then what they're doing is basically buying time. Because note this is very important. We don't know how much time we've got. This system is inherently chaotic. And if you think that there's a point in the future, like a little line in the sand over here somewhere, little line in the sand, there's a point where if we go past that point, we're in serious trouble. And you're visualizing it in your mind, in your intellectual mind, that there's this thing in the future. All we have to do really, really, truly, truly is determine where that point is. And then we know how much time we have as a result. And then we could stage our changes, space them out. So we reduce the amount of harm and confusion and terror in people's eyes and all this stuff. And we phase in the solutions until we get to that point. And so long as we've done all the work we have to do before we reach that point, then we'll be good. Phew, sigh of relief, right? But here's the problem with a chaotic system. You cannot know where that point is. You just can't. You can't say, well, we have until 2050. Well, by 2050, we have to have this figured out. You can't say that. As a matter of fact, I don't know that the point I'm alluding to, this point by which we kind of have to have our ducks lined up, is in the future. The line in the sand, the cliff that we're going to go over, might not be in the future. It might be in the past. You see the problem? Because we can't predict what the system's going to do, we also can't predict that it might have already done it. It's kind of slow moving anyway. And there's a lot of lag in the system, so that you can do a harm on date, in 2015, and the actual evidence of the harm that you did in 2015 doesn't show up until 2025, maybe even 2035. But the harm was done in 2015. If that's in your past, as today it is, if that's in your past, you can't undo that. And you're thinking, oh, well, that's okay. We'll just work a little harder. We'll really accelerate our improvements. But if that date at which you go over the cliff, the climate cliff, is not in your future, at some arbitrary point that you think you can demonstrate, it might already be in your past. That's kind of alarming. That's a little bit alarming. The equivalent of that would be the difference between your doctor telling you need to stop smoking, or in the future you will have lung cancer. That's one thing your doctor could say. Or your doctor could say, we did some tests and some chest x-rays, and I'm here to tell you, I've never seen you before. I'm a specialist. I'm not your GP. I'm here to tell you, you've had lung cancer for 2 years. That's the difference. you have a very different feeling about those two statements. Doctor telling you, you need to stop smoking cigarettes, or by the time you're 50, you're going to be looking at lung cancer. Or, hi, pleasure to meet you. I guess you're a smoker, right? You are, right? Well, guess what? You have stage 4 lung cancer. You've had cancer for probably 4 years already. And now it's stage 4, and essentially you need to write your will. So where are we with regards to climate change? James Hansen of Earth system scientist working with NASA, James Hansen, came before Congress in 1989, a long time ago, right? Basically 30 some odd years ago. And he said, oh, wow, we're changing the temperature of the planet. It's going up. And if we allow it to go over 1 degree C above baseline, the baseline is, you look back in time and you say, okay, the year 1950 or the year 1850 or whatever, that temperature back there, that's normal. That's normal. We're going to say that's normal because that's pre-industrial. That's normal. And then we started burning coal and then crude oil and natural gas. And so everything since then has been warmer because of the greenhouse effect. So if he said in the late 80s, they were coming up, the late 80s, James Hansen and his team were coming up with an estimate of what was going to be a bad day. And the bad day was, if we allow the Earth system to warm by more than 1 degree C, which is about, it's close to 2 degrees Fahrenheit, the entire Earth system, the average Earth system, 2 degrees Fahrenheit, above pre-industrial baseline, so 1850, pick whatever date it is, we're going to be in big trouble. That's going to be enough to alter the Earth's global climate permanently. Permanent alterations to the Earth's global climate. And we don't know what that's going to mean for humanity and civilization and other species and habitat in general. We just don't know. But we know it will happen, that we will irreversibly alter the Earth's climate system, average climate system, if we go above 1 degree C above pre-industrial baseline. He said that. They did work in the late 80s, and he made that statement to Congress under oath, the whole thing, 30 some odd years ago. Well, we are now about 1.5 degrees C, not 1 degree C, but 1.5 degrees C above pre-industrial baseline. And we're almost certainly going to 2 degrees C above pre-industrial baseline, just based on the fact that we're not taking hardly any substantive course corrections to keep that from happening. There's really nothing happening. There's nothing. And small things, but overall, it's nothing. Our fossil fuel consumption continues to rise, continues to go up. Our annual emissions of carbon dioxide and related greenhouse gases continues to go up. So we are still disturbing the system. We are creating warming pressures, solar forcings, as it were, to the Earth dynamic system. It's continuing to warm, and we will almost certainly exceed 1.5 by a long shot. And now people are in the business, now climate scientists are in the business of trying to estimate how much we're going to overshoot 1 degree C. And also, of course, the politicians are constantly moving the goalposts. So James Hansen said 1 degree C above baseline would be a bad day. And they basically came out and said, well, 1.5 degrees C is a baseline, and boy, we better not exceed 2 degrees C. And you can see what they're doing. They blew right through 1, even though that was the accepted benchmark, and now they're at 1.5, and they're going, now they have to move the accepted benchmark to 2. And then, of course, they move it to 2.5, and then they'll move it to 3. And that's just what they're going to do. Why? Because they're cowards. But the problem with all of this is that this is a chaotic system, and you should not be thinking that we know that there's a point out there where we have to stop for real, honestly, for reals, okay? and no backseas. You shouldn't imagine that it's just complicated. And there is a point, we'll figure it out, where we can't exceed that point and we'll be fine. This is a chaotic system. And for all we know, we've already, the point may be in the past when we've exceeded a safe limit. And if James Hansen was right about 1 degree C, and there are lots of people today who think he probably was, because we're already seeing deleterious shifts in the global climate. If you just accept that he was right, it was a good guess. I mean, they are scientists, so they have a reason for their guesses. It was a good guess. Well, then we exceeded that, I don't know, 3, 4, 5 years ago. We're already in the age of chaos. And I'm not really talking at that point about political chaos and economic chaos and societal chaos and refugees and all this other stuff and food insecurity. I'm talking about mathematical chaos. We are dealing with a chaotic system, and the more we push it, the more we kick it around, the more chaotic it becomes. And there's no reason for us to assume that the problems are in the future. We could have already tripped over something that has now blown up and is in the process of exploding. And that explosion might take 5 years or 10 years or maybe 20, but it's going to take a while. Is it the Greenland ice sheet becoming unstable? Maybe. Is it the Thwaites Doomsday Glacier becoming unstable? Could be. Is it the Siberian tundra in irreversible thaw? Yeah, it might be. Is it the methane bomb going off in the Laptev Sea? Yeah, it could be. There's lots of things we could trip over. Is it the irreversible degradation of the Amazon rainforest? Yeah, it might. That could do it. Is it the destruction through drought and pests of the northern boreal forests? Yeah, that would do it too. Lots of things that we're tripping over. Lots of things that are happening right now, or are predicted to happen, or are already in irreversible terminal decline. Lots of things, dozens of them. And we set off those bombs that are now in the process of exploding. It's a slow motion train wreck by and large, but it doesn't matter. It's still a train wreck. It doesn't matter if it's slow motion. It's a train wreck. And some of these train wrecks are maybe still in our future, a few years out, 5, 10 years out, until they become a train wreck. But some of these train wrecks are actually happening right now. They already have been triggered. They've already started. It happened 5 years ago. It happened 3 years ago, whatever it was. We've triggered multiple train wrecks, and and there's more in the future. And pretty soon, everything becomes a train wreck. These things accumulate. It's not like you have one train wreck and then you're like, phew, well, got through that. Okay, party on, Bart. It's one train wreck after another. And you can just imagine what that's going to be like. Or maybe you can't, but I can. And I'm trying to give you a clue. It's going to be chaos. Absolute, mind-numbing chaos. And not just chaos as in I can't find my shoes this morning, or there's no food on the shelves. Yeah, that kind of chaos, but also system chaos. The entire Earth dynamic global system in a state of irreversible, thundering chaos. It's already gotten to a point where their weather models, which are based upon past behaviors, they're predictive, but they're modeling a chaotic system. So what they are is they're statistical. Weather forecasting is statistical. When the wind comes down this way in the past, and there's a warm air mass coming up this way, and they collide at a certain space, and given their vectors and their speed and their mass, we think they're going to collide like right about here. And given this and given that, and we've seen this in the past, we've got all the data for 30 years or so, and on the other, 450 times that they came down almost like that, then there were thunderstorms along here and tornadoes along here, and lightning storms along this other thing, and it lasted 2 days, and it went to a certain speed, and the thunderstorms tracked along a certain line at a certain angle, and but it's predictive, but it's statistical based upon the past, because the system is chaotic. There really isn't a set of equations you can solve that says, given this equation and that equation, and it's a multivariate analysis, this is what drops out. It's going to be doing this. Okay, it's not like that. It's not predictable. It's chaotic. So you can look at past trends and say, well, we expect it to do this other thing a little later. But if that's how you're predicting your weather, then if the system that you're in now is on an excursion where now it is behaving, its internal dialogue with itself is different. It's moving in a different way because of all the extra energy in the system now. Then your predictions based on a past system are increasingly, with time, becoming irrelevant. Becoming increasingly irrelevant. We'll probably get to a point where weather forecasting is just a joke. We won't have enough data from the past to match the conditions that we're seeing in real time. We're going to be seeing conditions that are off the charts, meaning these conditions have never been seen before. But we can try and predict similar conditions will happen once or twice before, similar, not exactly the same, but similar. So we'll try to say it's going to do this, but it's a chaotic system. You actually don't know for a fact what it's going to do. And, our ability to do 10-day forecasts may simply dry up. Our ability to do 3-day forecasts might become a joke because your statistical methods for predicting weather were always based on something that happened in the past. And we're not there anymore. We're off the map. The heat dome that hit Portland, Oregon last summer that baked people, killed over 300 people in the U.S. Northwest and Canada, that heat dome was judged by climatologists and meteorologists as impossible. That was impossible. Not just unlikely, not, maybe even 100 years you'll see that. No, they said that was off the charts. That's just, no. What just happened? How did that happen? How is that even possible? Wait, no. That's what they were saying. They're saying this is off the charts. Should not have been possible. That should not have been possible. That was their words for it. So our ability to look at our climate system and say that at 1 degree C above baseline, it'll be acting like this. And at 1.5, it's likely to be like that. And at 2 degrees and 2.5 and 3 degrees, and here's a line in the sand. We better not cross that or we're going to be in trouble. That whole narrative is ridiculous. It's absolutely ridiculous. And for all we know, the line in the sand might have been 5 years ago. So what happens now? Well, we don't know. But this is why this whole meme about, we're going to fight climate change. That is nonsensical. Now, that doesn't mean you can't do anything. There are probably things you can do. So what is it you can do? When you have a complex system and you're concerned about its behavior, it's a non-trivial complex system. You know it's chaotic by nature, and you're concerned about its behavior, and you're concerned that if it becomes disturbed, it's going to go to a place that's bad. It's random and chaotic, and it's going to speedily go to a place that's bad. You don't fight that. You can study it, but when you study it, you still can't fight it. It's still chaotic. It's not chaotic because you didn't understand it. It's chaotic because it is. It's a 3-body problem. Probably a lot of 3-body problems. It is complicated and it's complex. The only thing you can do to fight climate change is you have to work within the reality that it is a chaotic system. And you don't want to disturb it. You like it the way it is. I mean, you can deal with the weather extremes. You can deal with the climate in your area. Maybe it's a little too cold in the winter, or maybe it's a little too hot in the summer. But by and large, you can deal with it, and you don't know. You're not willing to change it. Okay, we've learned how to live with this. We'd like to keep this, and so if that's your attitude, that the climate we had was not bad, and we just don't know what the future is going to hold if we mess with it because it's chaotic in nature, then the way you fight this is you actually stop playing with it. And to put it indelicately, you stop fucking with it. You stop poking it, elbowing it, pushing it around, slamming it this way, slamming it that way. It's a chaotic system. If you're doing those kinds of things, it's like dealing with nitroglycerin. You're going to slam it around and you think, well, this is fun, and then it blows up on you. So you don't do that. You just don't do that. Another thing you don't do is you don't talk about the climate system in terms of a complicated problem like, well, politics is complicated. Well, economics is complicated. Dealing with racism and social injustice and economic disparity. These are complicated problems, because there's politics involved and there's class systems and class distinctions involved and there's histories involved. It's complicated, okay? You can have those conversations about human level problems, the problems we create for ourselves, for our own entertainment, it seems like, because we keep doing it. But you can't have that discussion about the politics of climate change or the economics of climate change because it's not complicated. It's not human scale. It is complex. What you need to do is back off. You back away. As soon as you realize you're dealing with a complex system that is inherently chaotic, then if you like the way it's running right now and you're kind of happy with that, then you don't want to disturb it. You want to back off. Okay? And that's your solution. Now you're fighting climate change. You're fighting climate change, you're backing off. Whoa, hold on, Sparky. You don't want to fiddle with the knobs and levers on this. You better stop touching this thing. You better start knocking it around. You better stop playing games with it and doing experiments with it because this is an inherently chaotic system and you have no idea where this is going to go. It's going to go somewhere. That much we know. It's not that chaotic. It's not going to go into an ice age. It's going to get hot. That's just basic atmospheric physics. But what is going to happen to your weather, to your local regional climates, to your growth zones, to your frost line, to your degree days, to your crop planting cycles, things like that. We just don't know. It is inherently chaotic. And the way you fight climate change is you stop playing with it. You just back away. We will never understand it enough to find out the needle to turn, the lever to pull, the gear to replace with some other gear. What we do know is that burning fossil fuels and releasing the CO2 and related gases like methane and nitrous oxides into the atmosphere creates a greenhouse effect that warms the planet, and the planet Earth dynamic system is a complex system dominated by chaotic elements, and we don't know what's going to happen to it. And it's not that we're dumb. It's because we can't know, because it's a complex system dominated by chaotic elements. It's right there in the statement of the problem. And as soon as your problem is a complex problem dominated by chaotic elements, then you can't predict what anything you do is going to do. You may have vague ideas, okay? We do know that adding greenhouse gases to the atmosphere is going to warm the planet. All right, well, that's just atmospheric physics. That's not even chaotic. That's just how it's going to be. But once we do that and we start pumping that energy into the system, then where's it going to go? And how's it going to get there? And how long is it going to take? And when is it going to become irreversible? We don't know. And the most chilling thing for me is this possibility that the amount of time we have left to make the decision to back away, which I define as leaving fossil fuels in the ground, the amount of time that we have left in which to make the tough choices and just back away, leave it be, stop kicking it around, that date may not be in the future. It might already be in the past. Because we don't know. Because we can't know. And anybody who tells you they know probably either hasn't thought about the problem enough, or they're just whistling past the graveyard. Beautiful day. Look at the blue sky. Not seeing any problems. All the problems are in the future. It's looking great right now. That's whistling past the graveyard. And, your politicians and economists are going to be really good at doing that. Your scientists, your engineers, and your mathematicians in particular are going to be a little more nervous about saying, yeah, we're fine. Because we don't really know that. And James Hansen said the safe limit for warming of the planet on average is 1 degree C. We blew past that. We're already way past that. So was he right? Well, if he was, then the drop dead date for making a decision to stop messing with the system was about 5 years ago. That's what keeps me up at night. And that's why I'm making these videos. We're in for it. We are seriously in trouble. We are seriously in for it. I just don't know how this gets resolved. Our leaders are not leading. The people are not following. It's a complex problem with inherent, heavily chaotic elements. We don't know enough about it to even know which parts of it are most chaotic or which parts are going to run away fastest first. We're studying a system while it's in flight. It's like trying to change the engines on a jet once it's in the air. Wow. I mean, you can say it. Let's change the engines on this jet while it's in the air. You can say those words. You can construct that sentence grammatically correctly. But can you do it? All right, everybody, let's change the engines on this jet while it's in the air. Really? How? Well, we'll just innovate. We'll just figure it out. We'll just, don't be a Debbie Downer. Come on, be optimistic. Are we talking about changing the engines on the jet in midair? Yeah, sure. How hard could it be? Could be impossible. Defeatist. You're just a defeatist. You're just not trying hard. You're just a downer. You're just a doomer, saying we can't change the engines on this plane in mid-flight. Come on. There's got to be a way. Really? You think there's got to be a way? No, there doesn't got to be anything. I mean, if the engines are done and we're in mid-flight and we're over the middle of the Atlantic Ocean and the engines are done, well, then that's it. We're not changing the engine in mid-flight. Do you even have an engine? Do you even know how these things work? You're going to change the engines in mid-flight? I don't think so. Prayer. I mean, maybe we should start praying. And maybe we're supposed to, put on our life preservers or something because this thing's going down into the water. And no, I'm not a downer. I'm just telling you, you're not changing the engines of this thing in mid-flight. You're not doing that. I don't care if you can string together a grammatically correct sentence that says that, come on, guys, let's go change the engines in mid-flight. Yeah, you can say it. Doesn't mean you can do it. And don't tell me you're going to fight climate change. You can say that, and people will clap and cheer and light their lighters in solidarity. And you can say that, and people will, think you're a genius or something because now you're fighting climate change, and you get elected mayor or president or something. Moth, go away. You can say it, and you can get elected, and people will send you campaign donations. And I'm sitting here thinking, no. What? No, you're not doing that. It's not because I said so. You're not doing it because you can't do that. You can't change the engines on this jet in mid-flight. I don't care what you say. And I'm not a downer for saying that. You just don't understand what you just implied. You're saying things that you don't understand what you're saying, what you're implying by saying those things. And you can't fight climate change. You can stop messing with the system. You can stop pumping CO2 into the atmosphere and methane and other equivalents into the atmosphere. You can stop burning fossil fuels. Yeah, you could do that. You can do that. And maybe steer the course of climate change and maybe slow it down. You can slow down climate change. You can stabilize the climate change at some point and stabilize it earlier than 100 years from now, stabilize it 20 or 30 years from now. I mean, that's probably an improvement of something, maybe, possibly. Less pain and suffering. Yeah, okay, that sounds great to me. But fighting it, reversing it, taking us, no, we're not going back. No, goodness gracious. Where'd that come from? You think that? You're going to change the engines of this thing in mid-flight? No, we're not doing that. That's how I see it. You're not doing that. And nobody wants to hear that. Nobody wants to hear that. Okay. Well, like I am fond of saying, you can think anything you like. Yeah, honestly, you can think anything you like. That is your God-given right to think anything you want. Good luck. Good luck with all that.